Good morning, good afternoon, good evening. Hope you're all doing very well. Today we are going to discuss the second problem in the CP sheet by Daily Eliminators, that is the line trip. Let's get started. Let's start by reading the problem. There is a road which can be represented as a number line. You are located at point 0 of the number line and you want to travel from 0 to x and back to 0. 0 to x and back to 0. You travel by car which spends 1 liter of gas per 1 unit of distance traveled. When you start at point 0, your car is fully fueled. There are n gas stations located at the given points. When you arrive at a gas station, you can fully refuel your car to the maximum capacity. Note, you can refuel only at a gas station and nowhere else. You have to calculate the minimum possible volume of the gas tank that will allow you to travel from point 0 to the point x and then back to the point 0. Let's see the input. We'll have 1 to 1000 test cases and we'll have n comma x, that would be the number of gas stations, and x is the destination, right? And these are all the values at the number line where the gas stations are present. We need to print one integer, the minimum possible volume of the gas tank. What the question wants to start from point 0 to the point x, we need to go from here and back here, and we'll start with some, let's say, y amount of gas, and at some given points in between the journey, let's suppose these points are 3, 4, 7, 8, 12, we will be able to refuel our gas tank. So just for example, let's assume this is 15. So in between these distances, so to cover this distance, we want 3 minus 0, that is 3 liters of gas. Here we want 1, here we want again 3, again 1, again 4, and again 3. So going to here we require 3, from going here we require 1, again 3, again 1, again 4, and 3. So what we can assume is that at the destination point, at the gas station, our tank would be empty. So let's suppose that here we have a capacity of y, here it will be empty. So what would be the capacity here? So we'll assume that to be 3, right? In 3 we can cover this distance, this, and this, but for 3 we won't be able to cover this distance. So our maximum capacity needs to be 4. Right? So 4 is our answer. However, there's a catch in this question. From going to 12 to 15 we require 3, but at 15 the gas tank is not refueled. So we need to cover 12 to 15 and 15 to 12. That means we need to multiply this by 2, that is 6. We require 6 amount of gas in a gas tank to be able to complete the journey. So the maximum answer would be 6. I hope you got the approach. Let's see how can we do it. We'll just take the inputs and we'll make a difference array. Now difference array would store the difference between any two neighbors, like this minus this, this minus this, this minus this, and this minus this, this minus this, this minus this. And at the last difference, we will double it, and then we'll find the maximum element in the array, in the difference array. That is what we are going to do. Let's see how we are going to. We'll take the inputs, that is n comma x. We'll have the input array arr of size n plus 2. We'll initialize this array and we'll take the elements from 1 to n plus 1. The arr of 0 would be 0 and arr of n plus 1th index would be the x. Why am I doing this? This is because the first would be 0 and the last would be 15. Since we are making a difference array, these both will be very useful. Now again we'll make a difference array. Difference array, we'll populate it using arr of I minus arr of I minus 1, it will contain these values, and in the last element we multiply it by 2 and then find the maximum element. That would be our answer. I hope you got it. Now let's move on to the coding part. I will get my boilerplate code. We are given two inputs. Those are the n and the x. We are also given an array, and we'll initialize it with n plus 2. ARR of 0 is 0 and ARR of n plus 1 is x, as I had explained. And now we'll take the inputs. This would be our input. We'll make a new difference array. For every index we'll find the difference with the previous, so we'll start with 1 and we'll go on till the last element, and difference dot pushback ARR of I minus ARR of I minus 1. Now difference of the last element, diff dot size minus 1 is equal to multiply equals 2. We'll multiply the last element by 2. Now we'll have a variable maxi that will contain the value, that will contain the answer, like what is the maximum value that is required. So we'll iterate over the whole diff array. Auto I in diff maxi is equal to maxi comma I. In the end we'll just print the answer, that is the maxi. Let's try for the simple test cases. The answer is 437 and the answer should be 437. Let's copy and try and submit it. Submit. It is running, and it got accepted. I think you got the approach. Comment down what was your approach for the problem. Thanks for watching. Like and subscribe my channel. Thank you.